Okay, so here we have, and this is shared with you, so you have access to being able to use this diagram. Slideshow that kind of breaks apart the star chart, DHR diagram, so you can get some information. So these colors right here, anything that's in the green, you can see that is the giant or supergiant, which is called the intermediate stage. So these are the middle-aged stars. The main sequence stars are the young stars. So there's the biggest range in characteristics for those. You have main sequence stars right here that are big, small, bright and dim, hot and cold. So all sorts of masses. Young stars are all in what's called the main sequence, but there's the biggest variety of them. And then the oldest stars are the white dwarfs. So, and those are all generally warmer and smaller and dimmer. Now, you can get some basic information. So if we were going to say, look at Polaris, the luminosity of Polaris, I could slide this up. Okay, you can see Polaris was right underneath there. The luminosity is, it's over 1,000, but it's less than 10,000. And it looks like it's a little closer to 1,000, which makes it more massive than not. The temperature and color of Polaris. So if this is Polaris right underneath there, and I line this up there, looks like it's about 6,000 degrees K, which for all we need, that's like degrees Celsius. And it's a yellow color. All right, so wherever those two things intersect, you can just get the information off of there. Now, what is Polaris? And if we move these out of the way, which you can do with yours to look at some of the other details, Polaris right here. Let's look at some of these stars. If I have all of these stars over here, which ones line up with what? Okay, so this one right here is blue, but it's it kind of looks blue-white, and it's very small. That would be something like 40 Eridani b. You could see that right there. A yellow star that's like a medium-sized star would be something like either Alpha Centauri or the Sun. Okay, and a blue star that's kind of medium-sized would be something like Spica. And a reddish star would be something like Bernard's star. Okay, Bernard's star, it's a smaller star. I probably should shrink Bernard's star a little bit there. Okay, and that would be Bernard's star. Now this is a big star, but it's red. That would be something like Betelgeuse. And then this white star here would be something like, I could probably go with Polaris. It's more yellow than white. Probably would be more like, yeah, Deneb would be one of the white stars, which apparently you can't see through this one. But that would be about Deneb. Now here's the thing. Any star, these are all going to have a lot of hydrogen right here. Once the hydrogen starts to run out, the sun is going to turn into a star similar to Aldebaran or Pollux, but what I would have to do is make it larger, so it's going to get bigger, and it's going to turn red, so I would change that to a reddish color. Once our star, the sun, runs out of fuel, gets low on fuel, it's going to get bigger, but it's also going to cool off because it's moving this direction. And then eventually it's going to shrink down again, and when it shrinks down again, it's going to create a lot more heat. So it's going to shrink down, and it's going to move down into one of these and turn into a white dwarf style. But you can see I'm going to have to change its color more to a bluish white because it's now down there. So stars go from young. As they run out of fuel, they get bigger and cooler, and then they get warmer and smaller. So the same thing will happen with the stars that start off with more fuel, more stuff, more mass, are going to turn into more of a supergiant. Okay, and then the supergiants are going to eventually turn into like Betelgeuse. What was underneath here? Deneb. Those have enough mass where they're actually going to go supernova and turn into either neutron stars or black holes, which are not on our chart. So it's a whole different class right there. But each star has basically its own temperature and color, which depends on how much mass there is. The young stars with a lot of mass are over here. and the young stars with not much mass are over there.